It's me. Hi, Nathan. I thought I was going to be by myself, but it's good to know there'll be somebody else here. All right, it's 12 o'clock. We'll get started. I wasn't really going to talk very much about the pH and buffers lab. I'd make sure that you watch the Zoom session from last week if you want more details about that, but you'll definitely have to watch this video. I don't think it's going to be possible for you to do the actual report without watching the video. I think that's going to be due tomorrow night, so it's important that you get on that if you haven't already gotten on it. So what I want to do is go through the Le Chatelier's principle and solubility product. And again, for this one, what you'll notice is that I'll play a little bit of the video here. Not very much of it, just a little bit. And I want to point out that there is some stuff in here about the calculations that you're going to need to be doing, and what's going to be necessary in order to make sure you understand how to do all those questions. So that's sort of incorporated within the lab video. I still think it's worth watching the lab video. It's only going to be 20 minutes in total. That includes the explanation. So I think it's going to be well worthwhile getting on there and doing what you need to do with that. Now we've got a couple more people here. Does anybody have any questions about the pH and buffers lab before we move on here? Okay.
That one looked pretty straightforward to me, at least.
This one's not too bad. Le Chatelier's one. So you get 2 attempts at the results report again. So that's worth so just make sure that you do the best you can on the first attempt. and then you'll have a much better idea of what you're doing after that. But also go back and watch the video if you have any trouble with any of the concepts. All right. What else have we got here? The post lab is not too bad for the Le Chatelier's principle and solubility product lab. And everything is going to depend upon your understanding of Le Chatelier's principle. And that is, of course, part of what we're doing here for the test in the class as well. So understanding it here and understanding it there will be good for you. Anybody have any questions about the Le Chatelier's principle and solubility product lab? Okay, I also wanted to give a bit of a preview to the 10 dropper bottle mystery. That one is scheduled to start Thursday. I've got I made that a 2-day lab because that's how it usually is when we do it in the lab. Will it take you that long? No. Actually, this is a fairly short lab to do in an online environment. So it does give you a little bit of a breather as far as what's due, and sort of lets you take a little bit more of a breath here and figure out what you're doing. The instructions here, I've got some instructions for this lab, and these are the instructions. Read the lab, the whole thing. It has a lot of good stuff in it that'll help you to figure out how to do the lab. There's a video, it's only short, it's like 3 minutes, that shows you what these changes look like that are showing that there's some sort of reaction. And using the guidance in the lab document, do the ungraded practice quiz until you understand what you're doing, and then do the results quiz. There are no do-overs. Do not attempt the results quiz until you understand what you're doing. That means going through the ungraded practice quiz and doing that until you completely understand what's going on. So I'm going to show you what this ungraded practice quiz looks like. This is the well plate observations. That's the video I was talking about that explains what the changes look like. Let's look at the practice quiz. And your results quiz is going to look pretty similar to this. You all can see my screen, right? Yes? Good, thank you. So this is a data table that's going to result from results that you would have picked up had you done this in the lab. And what we're looking at here is just combining all of these different things and coming up with these results that appear in a table form. There's a key up here that tells you what the changes are, and that's why that video might be useful to you, so you can get a little context for what those mean. You'll notice that there's X's all the way down here. That's because we don't want to interact something with itself, so there's no reaction there. And the reason we end up getting half this filled is that if we're looking at, say, the addition of aluminum nitrate to sodium hydroxide, it's pretty much the same as adding sodium hydroxide to aluminum nitrate. So we don't really need to do that either. So that's what you're looking at. So what's the aim of this? The aim of this? Well, this is what the known reactions are. And this is a table of the same compounds, but in a different order to what they appear here in the knowns. So the idea for you is to go through and figure out 1 through 10, what each of those are, based upon reactions for what you know about the knowns. So that's going to be your challenge there for this one. Now the results quiz looks very similar to this. Obviously it's going to be something that's in a different order to what we're seeing here, but if you can understand how to do this, it stands to reason that you'll be able to do the results quiz successfully. So let's look through and see how we might do something like this. Well, first of all, what I would do is focus on the appearance. And over here, you've got light green and blue, and everything else is colorless. Obviously, the colorless ones aren't very much help to you. But the one that's light green and the one that's blue are going to be no-brainers for you to pick up down here. What do you know? Oh, there's a light green one. Oh, there's a blue one up here. So I know immediately what 1 and 7 happen to be. Right, so that's easy. Then we can use that, we can leverage that knowledge to figure out what the other things are. So what you can do is, and this is a sort of a technique that I like to use with these kinds of problems. If we're focusing on, say, let's look at the light green, that's going to be the, as I said up here, the nickel nitrate. Nickel is a light green one. The results for nickel then, since it's number 7, will be these 3 here and these up here. So these are all the different results for nickel that you see me following along with my cursor here. So I think that's good. So it's you look for the X here and you look up from the X and you look across from the X. What I would do is look for things that are unique here, and I see this purple solution. I don't see that in any of the other reactions for nickel anywhere along here. So then I can go back up here and I can say, well, what forms a purple solution with nickel? So I look along here, nickel, 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 purple solution. Oh, NH3. Oh, okay. So that tells me that NH3 must be number 5, because I know that 7 is going to be the nickel nitrate. And since we get a purple solution with number 5 here, 5 and 7, then I know that that must be NH3. And I can do that for all of these. Just look for the unique, excuse me, just look for the unique things once I know what something is. And then I'll be able to use that it's a kind of like a cascade at that point, because you get more and more information about what's what, and then it becomes even clearer as to how to figure out which number goes with which compound. Now, when you're doing the results quiz, you'll get one of these kinds of situations. Then underneath it, it gives you the opportunity to explain your rationale, explain how you got it. So it's all about the logic you used, saying for the start with the colors and how you knew which colors referred to which one, and then what they react with and what was unique in that reaction and how that allowed you to figure out something else, and then using that information to get the other compounds or ions that we're talking about in the results. It's actually kind of fun, but if you're having any problems with it, you can always contact me. Does anybody here have any questions about what they need to do for the 10-drop-a-bottle mystery? Well, that's pretty much all I wanted to cover today. Does anybody have any other questions about any lab type stuff that you want to talk about at this point?
I had one question that might be related to both this and the lab we're doing today.
Mm-hmm.
And it was specifically about the changes. So I can see on this chart the results, I guess, but I'm having a little bit of trouble thinking about, for example, in the lab where we were doing the cobalt complexes, and it was pink to start and then added something and then it became blue.
Right.
Is it that adding the heat to the pink side that makes it blue? Or I guess I'm getting a little bit confused, like where to put what is reacting together and then what's the product.
Okay. I'm going to try not to give away too much, but I will point you to some things to look at. Okay. Yeah, I get what you're saying. It's just a certain way of thinking about it. Once you get it straight, though, it's not too bad.
That's what I need, is the thinking. And I mean, I understand your hint to a degree, but I just want to make sure that I'm getting everything on the right side of the reaction.
Fair enough. Fair enough. Let's focus on part B here. We're going towards the reaction side, it turns pink. If it's going to the product side, then it turns blue. Right, so we've got our cobalt complexes that we're going to have here. One is pink and one is blue. And what was could you repeat what you said, Rebecca, about the heat?
Talking about where to put the heat in terms of the reaction, like the heat with the pink created the blue. And then
I
I
think
guess
that would be an
thinking
accurate
about the,
statement. That would be an accurate statement, Rebecca.
but thinking about the reaction chart that you were just showing, it shows very clearly, here's the result of whatever. But on this lab, sometimes I'm not always clear where to put all of the components together versus what the result is. I don't know.
The difference between this and the next lab is that this is an equilibrium, and we're actually messing with the equilibrium by changing things. In the next lab, all you're doing is reacting two things together and looking at the result. And then we're not changing that result at all. But with this one, we are doing different stuff to it. We can look at this and say pink, and if we add more Cl minus, we know that the solution will turn blue. If the solution's blue, we can add more water and make it turn pink.
Oh, okay.
Because we are messing with that equilibrium, which is the entire point of the lab. But your statement earlier about where to put the heat, I think, was an accurate one.
Okay.
And I think my discussion here is very useful in determining the answers to those questions. I do also talk about the endothermic and exothermic and relate that to the signs of delta H as well, which are part of the questions that you'll be asked about that.
Well, it was a little cryptic, just to be fair, but in the video, which is fine. But I think if I can restate what you just said in terms of like how the reaction goes back and forth, the COCl4, when you add water to it, then goes back to the pink. Yes. And then, you know, and then the cobalt complex with the water, if you add chlorine to it, then it becomes blue. And I guess you could substitute out water or chlorine with heat and see. So you're just saying you're adding something to or taking something away to see what happens.
That's right.
Equilibrium.
But what I'm saying is if you have a pink solution and you heat it and it turns blue, then you can easily determine that heat was a reactant that allowed that to happen.
Right.
Right?
Right,
and
because you added it to the pink.
That's right. That's right. But if you cool it, if you cool the reaction, you're actually taking heat away.
Okay.
And that would let's say that if it was pink and you added heat, it turned blue, and then you cool it, you take that heat away, right? And then that will go back to being pink because you're removing a reactant. So think about that. Think about it like that. If you're cooling it, you're actually taking heat away.
But you wouldn't write it as A minus heat is
no.
heat. It would be, you have to add the heat somewhere.
Yes, that's right.
Either on the reactant side or on the product side.
That's correct, yeah. That's
all right,
right.
I understand.
Yeah.
I understand. So it's almost like cooling is the inverse of adding heat.
I would think of it that way, yeah. I mean, if you were to put minus heat, and I'm just saying this as an aside here, you'd put it on the other side. It'd be just like a math equation.
I understand. Okay.
So think of it that way. The product minus heat would bring you back to A.
Okay, that's what I was trying to get after, is trying to understand how to translate what I see happening.
Yeah, it really is.
Equation terms.
Yeah, it is really just like that. If you think of it like a math equation, I think it becomes a little bit easier.
Okay.
All right. Does anybody else have any questions about this? Rebecca asked some really good questions that should be really helpful to anybody who watches this video. Anybody who's here today as well. All right. Does anybody have any questions? Any other questions that they want to ask about any of the labs I've talked about? The pH, the Le Chatelier's principal lab, or the 10 dropper bottle mystery lab? Anybody got any questions?
I do have a question concerning the lecture class, but I can wait to make sure everyone's done with this.
Okay, all right. I'll get you after that. And I'll stop recording too, Nathan, at that point. All right, anybody else got any questions about the lab here? Okay, I'm going to stay on the call. If anybody wants to hang around and listen to Nathan's lecture question, they're more than welcome to. And I will stop recording at this point.